Hello students, welcome to my class. Today we are going to discuss few questions related to NEET exam pattern. Clear friends? So let's start the question answer round, and my first question, look at which of the following does not produce any gaseous product when react with water. Before discussing this question, one more thing I am going to add, that is this chapter is totally theoretical chapter. You do not need to memorize the reaction, you just need to follow the tricks, techniques, just method to proceed the reaction, because there are number of reactions are there and it is not possible to memorize all the reaction. As during my lecture I have told you, it's better to understand the reaction rather than to memorize. Clear to you? So look at the question. Here is given, which of the following does not produce any gaseous product when react with water. What is given here? That is, friend, this one is water. H2O is given here. And first product is calcium nitride. We people know one calcium nitride Ca3N2 when treatment with H2O, then what will happen? So in this case one product is CaOH whole twice. Clear to you? If one product is CaOH whole twice, then the next one is NH. This is a gaseous product. So in this case, when a Ca3N2 is treated with water, then the product in this case is a gaseous product. Now if I talk about calcium carbide, as we know this is one of the famous reaction. When calcium carbide on treatment with water, what will happen? There is a famous gas C2H2. Formation of C2H2 take place, that is acetylene. Remember this, I have discussed during the reaction. If I put here CaC2 plus H2O, then what will happen? It gives CaOH whole twice plus C2H2. This is also a gaseous product. So this one and this one is not a correct option. Now let's move to the next part of the question. What is the next part of the question? That is CaO, quicklime. This is the one of the simple reaction related to water. As we know, when quicklime is treated with water, what will happen in this case? Tell me. So it will give you CaOH whole twice slag lime. There is no other product, formation of no other product take place. So here the question, which of the following does not produce any gaseous product? So in this case we people say that is CaO will not give any product, any gaseous product. What about the fourth option, Ca3P2, calcium phosphide? And as we people know, when calcium phosphide on treatment with water, it liberates, it gives a famous gas. Which gas, friend? PH3. Clear? Which gas, friend? That is PH3. So in all the four cases, third one is the case where there is a formation of only slag lime take place. But if I talk about this one, there is the byproduct, there is also a formation of gas take place. So as per the question, the C option is correct option. As I told you earlier, this is a totally theoretical chapter. You have to command the theory, otherwise it's not possible to solve the question. Clear to you? Basically you have to check out two things, that is the reactivity order and the stability order. If you know the reactivity order and the stability order, and then definitely you can proceed the reaction. And if you proceed the reaction, then I think you can easily solve question related to reaction or any other type. Clear, friend? So let's move to the next question. We are going to discuss the next part of the question. Wait for a moment. The next question is, look at, wait for a moment. Select the correct order of hydration energy. This is one of the most easiest and simple question, but frequently asked question. what is given here? Hydration energy. As we people know, small the size of the cation, higher is the degree of hydration. Higher is the degree of hydration, that is higher is the hydration energy. Remember this. As we know, when we move down the group, the size of the cation decreases. Tell me, am I right or wrong? Sir, you are wrong. When we move down the group, the size of the cation increases. If the size of the cation increases, then the degree of hydration decreases, because small the size of the cation, higher the degree of hydration. Higher the degree of hydration ultimately lead to the higher hydration energy. Clear to you? And if higher hydration energy, then lower conductivity, ionic mobility. In case of mobility, or you can say ionic conductivity. So what will be the order? So think on it. If I talk about lithium plus has a small size, then there comes Na plus. Yes sir. Then there comes K plus. So which will have higher hydration energy? Tell me friend. So it's very simple. Close your eyes like me and tell me Li plus, then come Na plus, then come K plus. So tell me what is the order friend? This is the order. Li plus, Na plus, K plus. So option A is correct. Clear? Again I am repeating, higher degree of hydration, smaller the size of cation. Smaller the size of cation, higher the degree of hydration, higher is the hydration energy, but less is the ionic conductivity. Repeating, less is the ionic mobility, or you can say ionic conductivity. Now let's move to the next part of the question. Which of the correct order of thermal stability? Tell me one thing. I am not telling anything about this question. If I tell this and this one, this is the figure, and if I talk about this and this one, now tell me which one has large size. So this one has large size, this one has a smaller size. So if we push it, then it will take time to it will take lots of amount of energy to break because size is less. But if I talk about this, there is a less requirement of energy to break. If size increases, bond length increases. If bond length increases, then you can easily break the bond. So if I talk about, now moving towards the question, if I talk about the first option, Li common, hydrogen common, hydrogen common, hydrogen common. But if I talk about boron, if I talk about aluminium, if I talk about gallium, when we move down the group, size increases, so less amount of energy required to break it. So in this case, which one will have high thermal stability? Sir, this one, because small size. So first option is correct. Now wait for a moment. Now check out the next option. Ca, Sr and B, Be, Be and common, F common, F common, F common. But if I talk about calcium, strontium, as we move down the group, if I talk about calcium, if I talk about strontium, if I talk about barium, then what will happen? So down the group size increases, so it is easily breakable. So this is also a correct order. Now check out the next one. Again what I am telling, if we move down the group, that is from calcium to barium, size increases. If calcium and this one is hydrogen, if this one is strontium and this one is hydrogen, if talk about this one is barium and this one is hydrogen, now it can easily be breakable because larger size, larger bond length. So in this case, what is the order? This is also the correct order. So A, B and C, all option A are correct. So check out the last option, all of these. So for this question, the option D is correct option. Clear, friend? Now I'm going to rub this part and we'll discuss the next question. Wait for a moment. What I'm telling, listen carefully. That is the question number 4. Decomposition temperature of CaCO3 is approximately 900 degrees Celsius, which are decomposed at less. As we know, if I talk about alkaline earth metal, what I'm telling, if I talk about alkaline earth metal carbonate, then what will happen? Down, if I talk about BeCO3, then MgCO3, then CaCO3, then SrCO3, then BaCO3. Am I right? Yes, sir, you are right. So down the group, the stability, the thermal stability of the carbonate increases. So if it is a boundary and if it will have 900 degrees Celsius, that is the decomposition temperature. So for strontium and barium, it will have a high value of it will require high temperature. But if I talk about Mg and BeCO3, this can be easily decomposed. So in this case, there is less than 900 degree temperature required, decomposition temperature required, but here more than 900 degree. If I take CaCO3 as a parameter. So what is the question? Decomposition temperature of CaCO3 is approximately 900 degrees Celsius, which decompose at less than 900. So less stability, so it will decompose easier, and the answer is BeCO3 and MgCO3. After decomposition, what will happen? It gives MgO plus CO2. Similar is the case BeO and CO2. Clear? Now I'm going to rub this part and we'll discuss the next question. Wait for a moment. Now the next question, which alkali metal has lowest heat of atomization? The question is, what is heat of atomization? Sir, the heat change, or you can say enthalpy change, to convert any elemental form, standard elemental form, into the gaseous form, that is 1 mole of gaseous form, that is heat of atomization. Like if I like here 1/2 Br2, during this change it gives Br gaseous form. If I write Na in solid form, it gives Na in gaseous form. So the total heat change during the conversion of standard form into gaseous, 1 mole of a gaseous form, during this the energy is known as heat of atomization or enthalpy of atomization. Lowest heat, as we know, if we move down the group, the size increases. If size increases, then it's very easy to convert. That is, first come lithium, second come sodium, potassium, rubidium and cesium. So this is the correct option, cesium. Clear to you? I think now you can easily solve such kind of question. As I told you earlier, this is a complete theory based question, and solving you can easily solve. Wait for a moment. Next one, come to the next one. Select the correct order of basic strength. Look at what is the correct order of basic strength. As I told you, if I talk about group 1 and group 2, group 1 and group 2, or group 1A or group 2A, in this case there comes lithium, sodium, potassium, then rubidium, then cesium, then francium, here comes beryllium, magnesium, calcium, strontium, and then barium. These are alkali metal and these are alkaline earth metal. They form bases of type MOH and they form bases of type MOH all twice. Clear to you? And these all form water soluble bases due to water soluble bases, and these are highly strong bases. As we move, we people know, as we move along the period, the non-metallic character increases and non-metallic, in this case the basic character decreases. So if I talk about KOH, this is the group 1, then comes here MgOH whole twice, okay, then there comes AlOH whole thrice, because this belongs to group 13. So order is KOH, MgOH whole twice and AlOH whole thrice. Check it out, KOH, MgOH whole twice and AlOH whole thrice. This two option is similar, so A and B both are correct. Clear, friend? Now I'm going to rub this part and we'll discuss the next question. Select the best method to prepare oxide of potassium. As we know, for group 1, they form oxide of the formula M2O, normal oxide. They form oxide of the formula M2O2, that is peroxide. They form oxide of the formula MO2. If I talk about potassium, rubidium, cesium, they form superoxide like KO2, like CSO2, so on. If I talk about the peroxide, that is sodium Na2O, normal oxide, it forms Na2O2 peroxide. If I talk about lithium, it forms Li2O, general Li2O2. So here, if you want to prepare the oxide of potassium, then what is the super good method? That potassium on treatment of limited oxygen, then it easily gives first K2O, then gives K2O2, then gives the stable one KO2. This is a superoxide. So in this case, what is the correct option? Sir, it's very simple. In this case, the correct option is reaction of K plus O2 limited, normal, per, and finally there comes superoxide. So what we say here, the C is the correct option. Clear to you, friend? Now I'm going to rub this part and we'll discuss the next section. Wait for a moment, friend. Now, next question is the reactivity order of 2A element with water. Now tell me, what is the reactivity order? We people know this. When we move down the group, if I write here beryllium, if I write here magnesium, if I write here calcium, strontium, barium and radium. Clear? Now there is less ionization enthalpy, ionization energy decreases, and if ionization energy decreases, then there is very powerful tendency to release electron. That is, the reaction will be powerful. That is, reaction complete in quick time. That is, the reactivity order increases. So when we move down the group, we people can say reactivity increases. So tell me, what is the order in this case? Sir, it's very simple. If I talk about beryllium, then there come magnesium, then there come calcium, then there come strontium, and then there come barium. So this one and this one is not correct. This is the correct option. Am I right? Now Now one more thing, tell me, what is the dissimilarity, main dissimilarity between the alkaline earth metal and alkali metal? Tell me friend. There is a basic dissimilarity, that is the stability of carbonate, bicarbonate and sulfate. The two things, the theory differs in this case. So while solving the sulfate carbonate stability order of sulfate, carbonate or hydrogen carbonate, or you can say bicarbonate, you have to check that the property differs in case of alkali metal and alkaline earth metal. Clear friend? I have discussed this question. Now let's move to the question number 9. Now this is your turn, you have to give the answer. What is given here? Look at. Which of the following exchange H plus ion by Ca2 plus or Mg2 plus in hard water? This is the question. As we all know, this is the method related to the removing the hardness of water. And what will happen, how to exchange, that is ion exchange resin method. I have discussed these things in hydrogen chapter, hydrogen and its compound. Remember this, that is what is hard water, what is soft water. If it gives leather, then it is known as soft water. If it does not form leather, then it is known as hard water. Hardness, what is the reason for hardness? Tell me, sir. Hardness is due to the bicarbonates or sulfates or chlorides of calcium and magnesium. And how to remove? There are many methods. If there is a presence of bicarbonate, then we people say this is temporary hardness. Remember this, just revision like temporary hardness. If there is a presence of sulfate and chloride of calcium and magnesium, we people say this is permanent hardness. Clear to you? How to remove the permanent hardness? One of the most important method which is used these days, that is ion exchange resins. And in ion exchange resin, there is a exchange of H plus ion by Ca2 plus and Mg2 plus in hard water. So what is the method in this case, sir? That is ion exchange resin, synthetic ion exchange resin method. So for this, B is the correct option. Am I right? Sir, you are absolutely right. What I am telling, again I am repeating, B is the correct option. Now I am going to rub this part and wait for a moment. Now let's move to the next question. Choose the incorrect set. First one, oxidizing nature. This is very simple. As we know, the fluorine is highly reactive, high electronegativity, then definitely the order is totally reversed. The oxidizing nature in this case, F2, then there comes Cl2, then there comes Br2, and then there comes I2. Clear to you what I am telling? F2, Cl2, Br2 and I2. So definitely first is the first option. This is first. This is not a correct set. Okay, this is the. Now check out the first ionization enthalpy. What is the order, friend? That is, I am moving here, sodium, lithium, boron and beryllium. Clear? As we know, if I talk about lithium and sodium, sodium has less ionization energy, because when we move down the group, easy to remove electron. If easy to remove electron from the outermost cell, then we people can say that is the ionization energy decreases. So in case of sodium and lithium, the order is sodium and lithium. Now if I talk about lithium, beryllium and boron, as we know, if we move along the period, then what will happen? There is very less tendency to release electron. So ionization energy, tell me, ionization energy increases because size also decreases. But here there is a contradiction. If I talk about this, that there should be the, this should be the order lithium, beryllium and boron. But as we all know, beryllium has electronic configuration 1s2 2s2, that is completely filled as subcell. If completely filled, then high stability, and in this case ionization energy is not less, ionization energy is more. So the order is lithium, boron, and then there comes beryllium. And the final order, tell me, sir, it's very simple. The final order is sodium, then lithium, then boron, then beryllium. I think now you can easily solve such question. This is the correct order. Now check out, okay, sodium, lithium, boron and beryllium. And the order is ionization energy, that is sodium, lithium, boron, and so this is not a correct order. So this is also an incorrect set. Now check out electron affinity. As we all know, the electron affinity order, that is in case of nitrogen, phosphorus, oxygen and sulfur. This is nitrogen, this one is phosphorus, this one is oxygen and this one is sulfur. We people know, as we move along the period, the non-metallic character increases, and hence we people know the electron affinity also increases. So the order nitrogen, then phosphorus, then oxygen, then sulfur. Down the group, here the cases nitrogen, phosphorus, oxygen and sulfur. So this case is correct statement. So this is not an incorrect statement. Now the aqueous ionic radius, this one, as we know, more the charge of cation, lesser is the size. So aqueous ion radius, that is Na plus, Mg2 plus and then Al3 plus. So Na, this is not a correct order. Here the order should be Al3 plus, aqueous ionic radius, then there comes Mg2 plus, then there comes Na plus. This is the correct order. So according to this, that is the option C is correct. 1, 2 and 3. Clear to you? Now again check out the next one, that is nitrogen, phosphorus, oxygen and sulfur. Nitrogen, phosphorus, oxygen and sulfur, that is electron affinity, or you can say electron gain enthalpy. First come nitrogen, then there comes phosphorus, and then there comes oxygen, and then there comes sulfur. Tell me, is there any possibilities, that is if I write here nitrogen, then down the group, okay, so the option is 1, 2 and 3. Clear to you? So if you have the strong theory, then you can easily solve such questions. Clear? Now one more thing I am going to add, as I told you earlier, if there is a strong theory, then you can easily solve such questions. Clear? So for S block element, you have to strong your theory, you have to focus how to solve the question. You just need to need a pathway to proceed the reaction. Just do not need to remember the equation, remember the reaction. Again reviewing the things, look at first one, tell me what is the answer. CaO. Second one, that is A option. Third one, tell me LiBH4, LiAlH4, Li, this one is correct, this one is also correct, this one is also correct, then all of these. Now let's move 4, which one? BeCO3 and Mg. A option is correct. Now which alkali metal has lowest heat of atomization? That is Cs, that is 6, that is KOH, MgOH aldehyde, AHOL haltride. Select best method to prepare oxide. Reaction of K with O2, that is limited supply. Now reactivity order, A option. Now this one is synthesis, synthetic ion exchange resin, and I have discussed this question also. So friend, this is the end of this lecture. We will meet you again. Thank you so much.